Recently, very important news were published about the Mars mission and the rovers on Mars. The first news with us says, first NASA Mars analog crew nears end of mission. The first crew to take part in a year-long NASA Mars analog mission reached the 300-day mark of its mission on April 20. The team of 4 volunteers entered crew health and performance exploration analog habitat at NASA's Johnson Space Center in Houston on June 25, 2023. And is expected to complete the mission on July 6, 2024. During their 300 days in the ground-based habitat, the crew engaged in multiple simulated Mars walks, grew and harvested several salad crops to occasionally supplement their shelf-stable food, and took part in habitat and equipment maintenance. NASA is leading a return to the moon for long-term science and exploration. Through Artemis missions, NASA will land the first woman, first person of color, and first international partner astronaut on the moon using innovative technologies to explore more of the lunar surface than ever before. The second news with us says, what's around the ridge bend? Curiosity succeeded on 14 meters drive along a bend in Upper Jeddah Valley's ridge to park next to Pinnacle Ridge, an outcrop of Ugver to the north. Benefiting from a surplus in power, Curiosity's already substantial targeted science block was extended to 2 hours. This allowed for the perfect imaging opportunity to look back and investigate the ridge deposits between a Pinnacle Ridge and Fascination Turret, an outcrop of Ugver to the south. In other words, most of the imaging opportunities in this 2-sol plan will be spent documenting what's just around the ridge bend with a detailed mass chem stereo mosaic and 2 chem long-distance RMI mosaics. Today I served as keeper of the plan for the Geology and Mineralogy theme group, where I was kept busy recording all of the geology-related requests from the instrument teams. The first sol involved planning contact science on a nearby dark tone float block, Sluggo Pass, possibly originating from Jeddah Valley's ridge. The composition and sedimentary textures of Sluggo Pass will be investigated with the alpha particle X-ray spectrometer, a chem passive raster, and the Mars Hanlon's imager. While constraints prevented brushing Sluggo Pass with the dust removal tool, the target appeared to be relatively dust-free. The rest of the science plan on the first sol includes a chem laser-induced breakdown spectroscopy targeting a dark tone coating on light tone bedrock, dubbed South Lake, and 2 small mass chem mosaics on blocks possibly associated with Pinnacle Ridge. After a planned 31 meters drive from our current location, the focus of the second sol of the plan will be on untargeted remote science. This includes one of ChemCam's automated autonomous exploration for gathering increased science activities where geological targets are automatically selected from the rover's navigation cameras for analysis with ChemCam. Additionally, environmental activities were also planned, including tau observations to assess the amount of dust in the atmosphere and maschem deck monitoring activities to assess the amount of dust accumulated on the rover deck. The last news with us says, NASA's CloudSat ends mission peering into the heart of clouds. Over the course of nearly 2 decades, its powerful radar provided never-before-seen details of clouds and helped advance global weather and climate predictions. CloudSat, a NASA mission that peered into hurricanes, tallied global snowfall rates, and achieved other weather and climate firsts, has ended its operations. Originally proposed as a 22-month mission, the spacecraft was recently decommissioned after almost 18 years observing the vertical structure and ice content of clouds. As planned, the spacecraft, having reached the end of its lifespan and no longer able to make regular observations, was lowered into an orbit last month that will result in its eventual disintegration in the atmosphere. When launched in 2006, the mission's cloud profiling radar was the first ever 94 GHz wavelength radar to fly in space. 1,000 times more sensitive than typical ground-based weather radars, it yielded a new vision of clouds, not as flat images on a screen, but as 3 slices of atmosphere bristling with ice and rain. Graham Stevens, the mission's principal investigator at NASA's Jet Propulsion Laboratory in Southern California, said, "For the first time, scientists could observe clouds and precipitation together." He said, "Without clouds, humans wouldn't exist because they provide the fresh water that life as we know it requires. We sometimes refer to them as clever little devils because of their confounding properties. Clouds have been an enigma in terms of predicting climate change. Clouds have long held many secrets. Before CloudSat, we didn't know how often clouds produce rain and snow on a global basis. Since its launch, we've also come a long way in understanding how clouds are able to cool and heat the atmosphere and surface, as well as how they can cause aircraft icing. CloudSat data has informed thousands of research publications and continues to help scientists make key discoveries, including how much ice and water clouds contain globally and how, by trapping heat in the atmosphere, clouds accelerate the melting of ice in Greenland and at the poles. Over the years, CloudSat flew over powerful storm systems with names like Maria, Harvey, and Sandy peeking beneath their swirling canopies of cirrus clouds. Its cloud profiling radar excelled at penetrating cloud layers to help scientists explore how and why tropical cyclones intensify. Across the life of CloudSat, several potentially mission-ending issues occurred related to the spacecraft's battery and to the reaction wheels used to control the satellite's orientation. The CloudSat team developed unique solutions, including hibernating the spacecraft during non-daylight portions of each orbit to conserve power and orienting it with fewer reaction wheels. Their solutions allowed operations to continue until the cloud profiling radar was permanently turned off in December 2023. Deborah Vane, CloudSat's project manager at JPL, said, "It's part of who we are as a NASA family that we have dedicated and talented teams that can do things that have never before been done. We recovered from these anomalies with techniques that no one has ever used before." CloudSat was launched on April 28, 2006, in tandem with a LiDAR-carrying satellite called short for the Cloud Aerosol LiDAR and Infrared Pathfinder satellite observation. The two spacecraft joined an international constellation of weather and climate tracking satellites in Earth orbit. Radar and LiDAR are considered active sensors because they direct beams of energy at Earth, radio waves in the case of CloudSat, and laser light, and measure how the beams reflect off the clouds and fine particles in the atmosphere. Other orbiting science instruments use the passive sensors that measure reflected sunlight or radiation emitted from Earth or clouds. Orbiting less than a minute apart, CloudSat and Calypso circle the globe in sun-synchronous orbits from the north to the south pole, crossing the equator in the early afternoon and after midnight every day. Their overlapping radar-LiDAR footprint cut through the vertical structure of the atmosphere to study thin and thick clouds, as well as the layers of airborne particles such as dust, sea salt, ash, and soot that can influence cloud formation. The influence of aerosols on clouds remains a key question for global warming projections. To explore this and other questions, the recently launched PACE satellite and future missions in NASA's Earth System Observatory will build upon CloudSat's and Calypso's legacies for a new generation. Earth in 2030 will be different than Earth in 2000. The world has changed and the climate has changed. Continuing these measurements will give us new insights into changing weather patterns. Thank you very much for watching. Goodbye.